Hello everyone. This video we'll be going to take one problem of max flow and we'll use Fulkerson algorithm to solve this problem, right? So I'm considering some max flow graph or flow network graph, and these are what the capacities of the graph. Now we'll be not going to take our generalization as we have the minimum number of edges. Though we have minimum or it is maximum number of edges, we'll implement this algorithm to find out the what is the maximum flow, right? Now we'll get started what is the flow for Fulkerson algorithm to solve this max flow. Now the algorithm is what? We will be initialize overall flow is equal to 0. Then we will be going to find out the augmenting path P. Until it ends, we will be repeat this loop. And for each and every path, we'll be going to find out the bottleneck capacity and to the overall flow. Overall flow initially it is 0. If you find any augment path, you will be calculating bottleneck capacity. Let's say that it is A. This A will get added to this 0. And till this condition fails, when the condition fails, when augmented paths are no or not existed in the graph, till that you have to repeat this. So when it is not generated, then you will be returning the overall flow what it has already you gained out of this bottleneck capacity. Now, so this is what the algorithm. Now we'll trace this algorithm with the example. The example is this, that you have 4 number of vertices with source and destination, and this is what the capacity. Fine. Now first of all, find out the augmenting path out of this. So initially, to understand, initially I am putting all zeros. So this is what the maximum capacity, and this is what initially it is all zeros. So find out augmenting path. Augmenting path is what? The path which is existed from source to the destination. So now the path is what I am considering. S2 to V2, V2 to V4, V4 to T. This is my first path. This is what? S2 V2, V2 V4, V4 to T. Now what are the capacities? S2 V2, the capacity is 12, V2 to V4 it is 11, V4 to it is 12. So augmenting path is the path which is existed from source to destination. Out of this you have to calculate the bottleneck capacity, and which is the minimum value among all these three, that is 4. Now 4 is what? Bottleneck capacity. So the condition says, if you find augmenting path, calculate the bottleneck capacity, add this bottleneck capacity to the overall flow. Overall flow initially it is 0. I am adding this bottleneck capacity which is 4. Now the maximum flow is what? 4. Maximum flow is 4. So you cannot take this as your solution, because algorithm says until you did not find augmenting path. So you find only one path, and until you find any other path, you have to repeat this. Let's see. So now take this 4 into your residual graph. You have to draw a residual graph concerned to that bottleneck capacity is influenced or affected. Now I am going to draw the residual graph. So now residual graph is what? The residual graph formula is what? The capacity of residual graph is calculated, capacity minus the flow. Correct? Flow value what you got? 4. Capacity already it is there with the edge. Now you apply this formula so that you will be finding out residual graph. So in this graph, you are not going to change the vertices of S, V1, V3, T, because we did not did any changes over here. These are same in the before question. Now the residual graph has been changed from S2 to T with the V2 and V4. Now focus how the way I am moving here. S2 to V2 there is a edge which is V2. S2 to V2 there is a edge with a capacity of 12. So capacity is what? 12. flow as what? 4. 12 minus 4 is what? Your residual capacity. So for make a note here, 8 is the residual capacity. Now, what is the capacity here? 12. If residual capacity is 8, there will be a opposite direction to balance this capacity with the value of 4. The same thing will be applied over here. So V2 to V4, actual capacity is 11. Residual capacity is what? 11 minus 4, which is 7. So 7 is moving this side and 4 will be moves at opposite side. And 4 minus 4, it is 0. So I am not marking any residual capacity because 4 minus 4, it is 0. You can also point out if you need, it is 0 and the opposite direction, it is 4. So you pointed out what is the residual capacity values in the following graph, correct? Now find, is there any other augmenting path? Because this condition will fail. You can fix your maximum flow value once this condition fails. So you have to check for any augmenting path. Now let's check for any augmenting path. The other augmenting path is what? The augmenting path is what? The path which is existed from source to destination. Now S2 to V1, V1 to V3, V3 to 2. There is a path. Now let's check. S2 to V1, V1 to V3, V3 to 2. This is what? The second path. This we were done. This is the second path. Now second path values are what? S2 to V1. S2 to V1 value is what? You have to consider the previous graph. S2 to V1 values are, I think it is 11, 12, 19. Out of these three, the value is 11. So out of, when you calculated augmenting path, you got bottleneck capacity which is 11. Now 4 is already augmenting path bottleneck capacity, 11 is second augmenting path capacity. Now draw the residual graph which is corresponding to this 11. So when I draw the residual graph, what is residual graph capacity? Capacity minus the flow value. Flow value you got, it is 11. So residual capacity is available with the edges. So 11 minus 1, 11, 0. 12 minus 11, it is 1. And 11 minus, here it is 19. 19 minus 11, it is 8. So these are what your residual capacities. Now again you cannot fix it is the overall flow. 11 minus 4, it is 15. You cannot say it is the maximum flow. When you can see overall flow, when it is overall flow is determined when you get this condition fails. Let's check for augmenting path. Is there any augmenting path? Let's check. S2 to V2. I'll take one more. S2 to V2, V2 to V4, V4 to V3 and T. This is also one augmenting path. The path which is existed from source to destination. Now all the values will get influenced again. S2 to V2, the path is what? 8, 7, 7 and 8. The minimum is 7. Augmenting path bottleneck capacity will be added to your overall flow. Bottleneck capacity is 7. Overall flow is what? 15 already there. 15 plus 7 which is 22. Now again draw the residual graph corresponding to this 7. Now your residual graph is this. So after you draw the residual graph, again find out for any augmenting path. Now this time augmenting path is what? S2 to V2, V2 to V1, V1 to V3, V3 to 2, T. Now the values are what? 1, 1, 1. The minimum value is what? 1. That means already you have 22 plus 1 is get added. Total 23 overall flow. Now find out for the residual graph. So what is the residual graph for this? Now again you have to influence this one in the above graph. So once after you find the residual graph for the above one, you will not find out any path from S2 to T. Because if you see here, from S there is no accumulated movement or any flow to the V1. Because residual graph values are turn to this side, right? 0 and to 9. So there is no augmented path which is from source. So as if you did not find any source from S point, there will not be any augmented path which is generated. So finally, the augmented path value is no. That means here this condition will get failed, and hence the overall flow will get written. The maximum flow of this graph is 23. So this is the way how you have to calculate until you find there is no path from source. Until you find that, you have to repeat this algorithm. So this is about calculating the maximum flow value using Fulkerson algorithm. Thank you all.